Potential tropical cyclone 9 officially designated in the Atlantic with hurricane potential in the Carolinas and a major flooding threat on deck. All the details in today's video. Welcome in, folks. Great to see you on this Friday, September 26th. And we got a lot to talk about today as we officially have potential tropical cyclone 9. Don't get used to that name because it'll be Imelda likely by tomorrow. And this one's setting its sights on the southeast coastline. But there's a lot to figure out still. We've got all sorts of tricks in the models. We've got a quite strange upper level pattern. We've got another hurricane next to this one. I mean, this one is complicated, folks. So we're going to try to break down everything we know. I'm going to give you my analysis in today's video and keep you up to date. Now, if you're new to the channel, welcome. My name is Gerald. I'm a meteorologist at WCCB Charlotte. If you haven't already, go ahead and like the video, subscribe, and hit the bell for the latest notifications. That last part's crucial, so you're always immediately informed when I have the latest data and I'm breaking it down for you. And again, we do that every day here on the channel. So a pleasure to have you this evening or morning or afternoon or whenever you end up watching this. But let's just go ahead and dive right on into things. So you can see next to me, we've got the latest run of the European computer model from this afternoon, and we've got tropical trouble showing up. Not just one, but two areas, actually. In fact, we've got what is already hurricane and probably already, honestly, major hurricane based on some of the data I'm seeing. Umberto, a little bit further off into the Atlantic. But then here's Imelda beginning to form by tomorrow and by early next week, Monday and Tuesday, making it to the Carolina coastline. And then that's when things get a little interesting and a little bit difficult here to forecast, and I'll be showing you why. But some models bring it inland, others stall it right along the coast. Some models just drop a foot to 2 feet of rain. Others not quite as much. So, definitely a bit to figure out here is the name of the game here. All right, let's give you a quick overview on satellite. We're going to dive into these systems more in depth one-on-one, but I just want to show you how rare of a look this is in the Atlantic. Now, here's Umberto. Like I said, already probably a major hurricane, a well-defined eye, a well-defined core, spinning away, rapidly intensifying today. It got hurricane status this morning. Probably going to have major hurricane status here by later on, again, if not already. Out here, though, this is a potential tropical cyclone 9, soon to be Imelda, whatever you'd like to call it. Either way, we're going to call it Imelda here soon enough, so get used to that name. And starting to look better organized today. You can see that kind of shrimp look to it. Here's your head, here's your tail. And, it's rare to get storms this close to each other in the Atlantic, and that's why the forecast is partially so difficult, as we could see some Fujiwara madness potentially going on. Although, again, that's a whole nother wrench in the forecast we're going to need to figure out. All right, I'm going to refresh it here and see if we have a new cone for PTC 9. Probably not quite out yet. Yeah, not quite, but either way, all the information you get in this video is still going to be useful whether we have a cone or not. I'll draw a cone for you if I have to. But you can see this is Umberto right now, technically only Category 1 as of this afternoon. That's going to change really soon. Let's just put it that way. Going to be a major hurricane, though, potentially Category 4 easily on the table. Can't rule out a 5, but I think a 4 is going to be pretty easy to come by as that begins to curve up and out towards Bermuda. At the same time, Imelda forming near the Bahamas, likely tonight into tomorrow, and that one going to move up in this general direction. And then once it gets right about here off the Carolina, Georgia coastline, that's when the forecast is going to get tricky. But I assume the NHC cone, and I'll get fact checked the second I post this, will probably look something kind of like this would be my guess. In that ballpark, obviously prettier than that, but you get the point. I think that's probably what they're going to end up making it look like. So that's a quick overview of things. Let's go ahead now and dive into these storms one by one, analyze their current atmosphere around them, and kind of predict, or at least try to, based off those current observations, where things are heading. Let's start with Umberto and get kind of the easy one out of the way. This one, just a powerful hurricane already right now. You can see that well-defined eye as you saw on satellite, and a very compact storm. And generally speaking, the more compact these storms are, the quicker they can rapidly intensify. And that's exactly what's happening right now with Umberto. That's what it looks like on satellite. Well, why is it doing so well? Here's part of it. No dry air around the storm. You can see here, as we kind of look around, all the dry air is pretty well displaced from the center of this thing. Also, looking at deep layer shear, it is in a perfect pocket of green right now, just allowing this thing to just stack itself vertically, which always helps these storms become stronger. You add on top of that, and I'll get rid of the shear there and the dry air so we can see a little bit easier. Warm waters and going over even warmer waters. This is, 28, 29 degrees Celsius. It's more than warm enough to produce a major hurricane. In fact, not only is the water warm, that warm water goes quite deep as well, which is not loading. Oh, yeah, it is. It's the wrong button. There you go. You can see again, going pretty deep, down to potentially 100 meters or so of that very warm water. And you put all that together, the MPI, or the max potential intensity of a storm like this, could easily get into the low 900 millibar range. So that's why the NHC is expecting Category 4 status. All the signs point to that, with a pretty pristine environment. And again, that warm water going to be warm enough to get this quite up high on the echelon of hurricanes. And we'll see if we have any other data on this. Let's see if we've got any scatterometer passes. Yeah, it looks like it, actually. So you can see scatterometer pass, at least the latest ones, definitely showing we've got a very clear, well-defined cyclonic flow. No surprise, we could see that on satellite. You don't need the data to tell us that. It passes the eye test more than enough. We'll see if we have any AMSU data here, which doesn't look like it. We do have some ATMS data. This shows how warm the core of the storm is. I'll get this off so we could see it again. And notice, yeah, we've got a pretty warm core here. Once you start getting into these colors here on the key there on your right, these greenish colors, that indicates warmer than the surrounding air. And yeah, definitely a well-defined warm core here on channel 8. Let's see if channel 7 has it. Yeah, you can see a bit of a warm core on channel 7, channel 8 as well. I think I said channel 8 earlier. This is channel 6, excuse me. Channel 8 data here showing, yeah, very warm core. So same thing for channel 9. It's what you'd expect. We've got a hurricane, basically, is what the data tells us. And as expected, and as I showed you earlier, with the shear ahead of this thing, it's not going to slow down anytime soon. So I fully agree with the NHC forecast of a major Category 4 with this one. Makes complete sense. And you could see as well the track from the National Hurricane Center making plenty of sense, as basically all those little lines are ensembles and such, and all of them basically right in the center of the cone from the NHC. All right, let me show you, I guess, maybe one more thing here, and then I'll be done with my meteorological tangent here on Umberto. We've got plenty of low-level convergence and upper-level divergence. That's a key with this one as well. The lower-level convergence there is going to be in your blue color, upper-level divergence in your yellow color. You're thinking, Gerald, why is that important? Well, when you have a lot of air coming together at the surface and spreading out apart, that means this thing is balanced and it's feeding itself quite well. That's helping to increase the wind speeds, lower the central pressure, and just strengthen the storm. All right, that's Umberto. Let's get over to potential tropical cyclone now, soon to be Imelda, and go through this exact same process and try to figure out kind of what's on the way here in the near term. All right, let's do it all again, but for PTC9. And again, I'm probably just going to call this one Imelda through much of the video, because that's what it'll be likely by the end of tomorrow. All right, so you can see, like I mentioned earlier, starting to get there today, looking more organized and getting that kind of shrimp look. And anytime you see that in the tropics, it's a sign that things are starting to strengthen. So why is that? Why is the system finally starting to get its act together? Well, one, you can see this tiny little area that they're estimating the center is at is more over water today than yesterday, kind of riding the southern tip of Cuba a little bit here, but off of the higher terrains of Hispaniola. And yeah, we've got some mountains in Cuba, but this part not quite as tall as Hispaniola, where the current estimated center of the storm is. How about dry air? Well, that's another thing. Not a whole lot of it around the system, so it's got plenty of moisture to feed it. There's some dry air further to the north, kind of between the Bahamas and Bermuda up this way, but that's far enough away that it's not really impeding the storm. What about deep layer shear? Still some shear around it, but we've got some green starting to work in here now. You can see this little pocket of more favorable shear, basically right where the center of the storm is. And even the unfavorable levels, not off the chart levels of unfavorable. It's manageable enough that with the moisture and what you're going to see next in very warm sea surface temperatures, it's enough for the storm to kind of get its act together. So let's show you those very warm SSTs. Off the charts here, folks. This is some of the warmest water in the Atlantic. We're talking about 30 degrees Celsius. That's not too far from 90 Fahrenheit. Just explosive levels of fuel here. And much like what Umberto is experiencing, this goes deep. Again, some of the deepest warm water in the Atlantic, 100 to 125 meters below the surface of the sea. That warm, very unstable column of warmer ocean temperatures, are sitting. So you put all that together, a little wind shear not going to quite be enough to kill this one. And I think that's why it's really beginning to organize. Also on top of that, if we take a look at the convergence and divergence I showed you earlier, also, those are starting to stack here, meaning, yeah, we've got low-level winds coming together, upper-level winds spreading apart. That's helping to deepen the pressure and organize the spin here down below. So another favorable thing ongoing. And then the vorticity also beginning to increase with this one. So This one will be Imelda by tomorrow evening. I'm very confident in that, unless something crazy happens. If this wind shear can work some magic, that would be great, but I'd be shocked if we don't get at least a weak tropical storm by the time we switch the clock from Saturday to Sunday late tomorrow, and that's why, we need to be careful. Also, I mean, these warm sea surface temperatures, let me zoom out a little bit here. You could see extend all the way up through the southeast. So this one's got warm water to work with as it works through the Bahamas. Again, that warm water going quite deep. You can see ocean heat content plenty deep enough out here. And in terms of shear, I'll switch it back to satellite. I know it's a little messy, but we've got pretty favorable shear here north of the Bahamas once it gets past this little area of higher end shear. And like I've mentioned, not a whole lot of dry air. One little pocket out there, but that one not going to be able to do a whole lot here in the near term to slow down the progress of this system. So that'll be very important. We'll have to see what happens with this one over the near term. And I forgot to check. Let's see if we have any scatterometer passes over this one. Doesn't look like it. Would love if we had some microwave imagery. It doesn't look like we have any of that as well. So not a whole lot of satellite data, but the hurricane hunters are starting to get in here, and we'll get more info on potential tropical cyclone 9, which will go into the overnight models. And, we should have hopefully maybe not a perfect forecast, but a much more fine-tuned forecast by tomorrow. Speaking of those models in that forecast, let's go ahead and get to the fun part and start analyzing that data and try to piece together what in the world is going to happen here over the next week. All right, before we dive into all of the crazy model runs I'm going to show you, let me preface a couple things to start off. One, these are model runs. This is model guidance, meaning this is not a perfect forecast, but these are the tools that I'm using to create a forecast. So that's very important to know from a meteorological standpoint. Big difference between modelologist and meteorologist. Meteorologists use the data they're given, try to find their flaws and come up with a good forecast. Modelologists will just look at a model and tell you that's what's going to happen, and they're wrong 9 times out of 10 because of it. So that's important. Also, this is going to change a little bit. Now, I don't expect any huge swings in the forecast from this point. I still think what I'm going to show you, the different possibilities, it's going to be one of those 2 or 3. But those are just some important things to take away here at the beginning. We'll start with the GFS, and this is all the latest data that we have. We'll start here by tomorrow afternoon and evening. Notice by this point, the GFS, assuming Imelda is fully named and fully formed into a tropical storm right over the central Bahamas by tomorrow evening. And then Umberto out here, probably, even stronger than what is being predicted on this model at around 966. Again, I think it'll be even stronger than that by tomorrow afternoon and evening. Keep it going ahead into time. Here comes Imelda riding up the East Coast a little bit. And by Sunday evening, we've got we'll call it a stronger tropical storm, borderline Category 1 hurricane pulling north towards the Carolinas. By Monday afternoon, same thing, probably around a Category 1 storm approaching Charleston, starting to impact the South Carolina, Georgia, and North Carolina coastline with some gustier winds and some rain, and then working inland and just barrels into the Carolinas right through about Columbia by Tuesday afternoon, and then parks it there and just meanders for a while with on and off rain. And then you can see Umberto safely passing between the United States and Bermuda on that run, but still as a major hurricane. That's the GFS model. Let me show you the European now, and I'll show you the latest data on this side. It's got to look a little different, but it'll be okay for the purposes of this. Here we go. Saturday afternoon and overnight Saturday into Sunday. Here comes Imelda forming a little bit slower on the European model in the near term. So that'll be a very key difference in terms of what actually happens. If we get a quicker formation, we'll probably be closer to the GFS solution. If what will become Imelda takes its sweet time tomorrow, then maybe we're a little bit closer to what the European shows. And that's possible. Again, we got some shear out here. So maybe this does take a little bit longer. And then Umberto, just a vorticity machine here, just spinning away off into the Atlantic. All right, Monday morning, similar to the GFS at this point, moving up now north of the Bahamas, a little bit slower than the GFS, but similar with the tropical storm, and then becoming a hurricane by Tuesday morning. So now we're getting delayed between the European and the GFS. By Tuesday, the GFS already has this thing about halfway up I-26 in South Carolina, probably close to Orangeburg. The European model getting a hurricane right between probably Charleston, Myrtle Beach, but right offshore Tuesday. And then Wednesday morning, it hasn't really moved, folks. It stalls right here off the coast, batters the Carolina coastline all day Tuesday with winds, surge, rain, and just sits there and then finally tries to work in and just lingers over the southeast all the way through early next week. In fact, probably goes out to sea a little bit and then back into sea. I'll show you why in a little bit, but it's going to come down to Umberto here. Umberto is actually what's trying to pull it back out and then loses that effect and goes back in. Again, we'll break down the steering currents in a moment, but for now, we're just showing you the raw model data. All right. Those are two models. Let's go ahead and switch on over now and take a look at two more models and just keep on running with the model train. All right, let's keep it going. Here's the Canadian model. What does it show? And the Canadian can be reliable from time to time. In fact, we'll switch this back to the precipitation map so you can get an idea a little bit more of what this would look like, probably for what you're more used to looking at, which would be radar. Okay, Sunday afternoon, we've got a tropical storm here near the Bahamas on the Canadian. You've got Umberto, again, probably stronger one than what this model shows. Keep it going, though. Here we go. By Monday afternoon, a little closer to the European, slower than the GFS, about the same intensity, then gets out of that little pocket of shear and starts increasing into a hurricane by Tuesday afternoon. Doesn't get as close to the Carolinas as the European, stalls further offshore, then starts to hook back out to sea, stalls again, and then hooks back inland and doesn't make landfall until next Saturday on the Canadian. I'll start by telling you this, folks. If I'm still dealing with this thing by next Saturday, I'm going to throw a fit. So hopefully the Canadian's wrong, but it's a possibility, and I'll show you again why in a moment. And the Canadian's not the only one showing this. This has kind of been the theme today. It's a bit more of a stalling scenario. Here's another model run. Here's the Euro AI. Let's see if we have a precipitation one for this one. We do. So we'll show you this format again so it looks a little bit cleaner. Here we go. Tropical storm forming over the Bahamas over the weekend. By Monday afternoon, right about where the Canadian and the normal European have it, just north of the Bahamas, and increasing in intensity. Then the Euro AI, very similar, kind of stalls it, slows down Monday and Tuesday off the southeast coastline, not nearly as close as the European, tries to go out to sea and then stalls and then tries to hook back towards land, but actually gets a little bit closer to the northeast and rides up the eastern seaboard. So we've got some differences in the models, to say the least here. And to put it lightly, the GFS plows this thing right inland. The European AI, the Canadian, stall off the coast, pull it out, and then try to move it back in. The European, kind of an in-between solution, gets it near the coast, stalls it out, and would be a flooding nightmare with a situation like the European. So that's kind of the raw data. Let's take a look at some more environmental factors on some of this data and then show you the hurricane models, which generally speaking are a little bit more reliable, and we'll keep the train running here on data. I'll tell you this, I don't think Imelda is going to be a perfectly pretty major hurricane upon landfall if it makes a landfall. Here's why. We've got a lot of dry air over the southeast. You might not realize it right now because it's muggy, it's soupy, and we've got rain out there, but we've got a frontal system approaching. You can see all that dry air trying to work to the east. This is by Saturday morning. Here's by a Sunday morning. Here's by Monday morning. You can see what starts to happen is all this dry air in the southeast starts to scoop in and around Imelda, and again, what would become Imelda, and it starts to get pretty ugly looking, I'll say. Now, an ugly storm does not mean no impacts. In fact, something to notice is out in front of this thing, you've got a lot of moisture funneling up into the Carolinas by Monday with a situation like this. And yeah, on the south side, it's dry, but the south side is over the Atlantic. So what does that really matter for us, besides the fact it'll help keep intensity maybe at bay a little bit? But that's a lot of moisture getting thrown right into the Carolina coastline. That would bring some surge. That would bring flooding potential. Could bring some gusty winds. And the GFS keeps that trend, almost tries to get it back to life a little bit, finds some moisture over the Gulf Stream, strengthens one last time before moving into South Carolina, at least on this model run. But either way, you can see that dry air around. With or without the dry air, though, on the north side, looks like a lot of moisture, and that's where all the land is, unfortunately. Another little interesting tidbit that somebody brought up on social media was a great point with this. When you get dry air and training into these systems on the backside, that can bring some problems. One, that could increase the severe weather threat. When you get dry air here into the mid-levels, that increases instability from time to time and can kind of create gaps in between these feeder bands, and that can sometimes help create a bigger tornado threat, so we'll need to see if that's something. Also, when you get dry air into the backside of these systems, that creates evaporational cooling, and that creates cooler air, obviously, is in the name, which brings that cooled air down to the surface and can mix some pretty strong winds on the backside of these systems down to the surface. So that's a whole nother piece of the puzzle to find out. But remember, ocean temperature is very warm out here. That's not something that is going to slow the system down, but maybe dry air will. What about wind shear? Well, we do have a bit of a jet stream in here, cut off low. And honestly, it could help, it could hurt us. We have two types of trough interactions with tropical systems. We have positive and negative. A positive one can actually strengthen a system. A negative one can weaken it. To be determined how it'll work with this one, but there are some signs in some of the models that actually the upper level flow kind of fans this out a little bit and helps it. So that's another component. But I think that if that happens, it'll only be for a time. It might at first help the system a little bit, but eventually, as it gets closer to the coast, probably with frictional forces on top of some upper level shear, that should help us out a little bit as well. Those are the environmental conditions. Now let's show you those hurricane models, and you can kind of see how the global models with their ingredients and the track kind of all come together and give us a pretty good picture of what may end up happening on a more mesoscale look with these models. Let's show you some of these hurricane models, oftentimes one of the more reliable tools to use. Here's the HWRF model by Sunday morning, showing a tropical storm trying to become a hurricane over the Bahamas and then getting north of the Bahamas. And here we go by Monday morning, continuing to strengthen into a Category 1, Category 2 storm. And pretty similar to the GFS here, by Monday evening, plows this thing right into the Carolina coastline here into South Carolina. Again, by that time frame, later Monday into the overnight of Tuesday, plows this thing right into the PD as a hurricane, brings tropical storm conditions into the Piedmont of North Carolina, brings heavy rain, brings a flooding threat, brings it all, really, including probably a severe weather threat with a look like this. That's one model, and you can see kind of stalls out a little bit and then tries even going back out to sea there by the end of the run. So, it's got that look a lot of the models have, at least what the GFS had and some other models, which you'll see here in a moment with the spaghetti plots. Here's another model. Here's the HAFS-A model. This one a lot closer to the European model. Here you go, developing into a hurricane by Monday afternoon north of the Bahamas, continuing to pull north. Looks like it's going to make a landfall into Georgia even on this run, which can't rule that out either. Then stalls like the European does and just lashes the Carolina and Georgia coast through all of really Monday, Tuesday, and even into Wednesday, although at that point starting to weaken due to some frictional forces and probably some cooler waters right along the coast. So a lot going on there with the hurricane model. So let me show you why this is such a difficult forecast in terms of the track. Well, we've got some very interesting upper level steering currents, and let me make sure I can get my tab to actually work here. Let's see. All right, you can do it, computer. I believe in you. There we go. All right, let's show you this. Sorry about the technical difficulties, right? All right, this is the European upper level map, 500 millibars. This is why the forecast is tricky. We'll pause it here Saturday afternoon, and let me play out all the pieces for you. We've got upper level trough here over the southeast. We've got Imelda here, and then I'll circle Umberto in yellow just to give it a different color. All right, this is how this is going to want to work. This trough over the southeast is going to want to pull Imelda right in like the GFS does. Umberto, because it's stronger and due to those Fujiwara effects, is going to want to pull Imelda back out to sea. So the question is, which one wins? Well, if Imelda's quicker, gets stronger quicker, starts to pull north, that upper level trough is going to win. It's going to pull it right into the southeast. However, if it starts to, maybe we'll call it strengthen, how about that? A little bit slower, and Umberto is a little bit quicker and stronger, which already is running stronger, and Umberto gets close enough right around here as the system gets close to the southeast, Umberto is going to want to pull it back out to sea, and that's why you've got kind of this tug of war that the European is showing that stalls the system out. So, which one's going to happen? Is it going to get thrown inland or is it going to go out to sea? Well, let's take a look at some ensemble data and try to figure out what the main winning solution is right now, and then we'll end things out by showing you some of the potential impacts from this storm. All right, here are the European ensembles, and we'll just kind of move it ahead into time, and you can see what happens. All these lines being one of these ensemble members showing the future track. A lot of them throw this right into the southeast, into the South Carolina to North Carolina coastline. Charleston to Wilmington is kind of the key place that most of the models want to do, that sort of landfall. But you also have a cluster here that tries to pull it just back out to sea before it ever even gets there. So that's still a possibility on the table. This is not a slam dunk, going to make a landfall forecast, but a majority of the European ensemble members do bring this into the southeast, specifically South Carolina, North Carolina, and then kind of pull it along I-20, and then later on almost try to loop it back out to sea a little bit later on into the run, and just keeps it hanging around longer than you'd like to see in the tropics. The GFS ensemble members, remember the GFS is the one that just plowed it right into South Carolina and then killed it inland. Its ensembles agree, but honestly, trending closer to the European today, where it gets about halfway through the Carolinas, stalls out, and then tries to loop back out to sea. So I think that's been a big theme in the runs today, and in the data I'm seeing and getting is it's going to get very close to the Carolinas. That could mean a landfall. That could mean it gets all the way in towards Columbia. That could mean it doesn't quite get into an official landfall and then just kind of stalls. It reminds me of Debbie a little bit from last year. And remember that one dropped a ton of rain. Also had a dry air intrusion into that storm. This is a relatively somewhat similar setup, honestly, outside of the fact that we have another hurricane trying to steer it off. But in terms of kind of breaking down steering patterns in a tug of war, it does remind me that of a little bit. And obviously Debbie was one that brought big flooding concerns. So that'll probably be the biggest concern with this one as well. All right, here's some AI model data. The AI model data, as you saw with the operational runs, a lot less excited about the idea of this making landfall. Most of this just stalls it offshore, pretty far offshore even, and then has Umberto take it out to sea, and then stalls it again, and then tries to bring it back inland by next weekend. If that happens, folks, I'm already pretty tired, but I'm going to be even more tired of the tropics. I'm never going to track another tropical storm again if that ends up happening, but we'll hope not. Still goes to show just so many possibilities. So let's summarize. What are the big three options on the table? Option one that I think is the most likely right now is this gets into South Carolina, North Carolina, is probably a tropical storm or weak hurricane. That could even mean a category 2, I think would probably be the upper echelon right now, and then kind of stalls out a little bit inland and causes some flooding. Option 2, it gets towards the coast of the Carolinas, stalls right along the coast, for a day or two, brings ongoing flooding, surge, and heavy rainfall, but not quite as far inland. Option 3, let me not do the middle finger there, almost just gave everyone the bird by accident. Option 3 is it doesn't get that close to the coastline. It stalls out further offshore and then goes out to sea a little bit. And then semi-option 3/4 is it goes out to sea a little bit, then either keeps going out to sea or brings it back inland. And I know those are a lot of options, but I think this is the most likely one right now. As it gets towards the coast, stalls, maybe a little bit inland, maybe a little bit offshore, and either way brings pretty big impacts. Speaking of those impacts, let's take a look at potential rainfall totals and even some potential wind gusts out of this storm. If you made it this far in the video, congratulations, you get a bit of a treat, and that's the first official cone from the National Hurricane Center. I ended up talking so long today that the National Hurricane Center had enough time to draw up this cone. So let's show it to you. They are officially forecasting a Category 1 hurricane just offshore the southeast here by Tuesday afternoon. You can see that H1 being a Category 1 storm, and then stalling, just like I just showed you in all the model data. And they've got about a 50-50 shot at stalls inland or offshore, right along the beaches. So obviously an annoying one to forecast here. And because of that stalling motion, you run the risk of flash flooding. And that'll be a big topic of discussion here. This is the latest European model run. Look at these rainfall totals, folks. 16 inches, 21 inches, 25 inches. That's catastrophic levels of flooding potential. Again, with this flooding idea or this stalling idea, it brings such a high risk of flooding we need to keep an eye on. Even brings, half a foot to a foot inland to places like Columbia, Charlotte, Fayetteville, not far from Raleigh. So everyone in the Carolinas, will throw in Virginia and Georgia, need to watch this one like a hawk for flooding potential, maybe severe weather potential, and all sorts of things. Now, other model data, it keeps it more of a confined path of heavy rain, like the GFS, one that plows it right inland. Again, just brings a swath of, still a foot of rain, which is a problem, but not as widespread as the storm. Doesn't quite stall as much and just works inland. And stalls a little bit inland, but starts to lose some steam by that point on the GFS. The EPS, the European ensembles, you can still see that blob idea, the highest chances of heavy flooding rain, kind of I-77 eastbound on this run. So lesser numbers out towards the upstate and higher numbers towards Fayetteville, Myrtle Beach, Wilmington, kind of surrounding areas, including Charlotte and Columbia, getting walloped pretty good on that. And then here's the blend, everything kind of put together. Final thing I'll show you in today's video, potential winds, and I'm showing this one to you with a grain of salt because, again, we really don't know exactly where this thing's going to end up. But wherever it does end up, we could see hurricane force winds. Would not shock me. You can see on the European here, get some hurricane force winds along the South Carolina coastline by Tuesday afternoon. Kind of backs up what the NHC forecast is. And should it work inland quicker like the GFS has, we could get inland tropical storm wind gusts, maybe potentially as far inland as places like Columbia, Charlotte, Fayetteville. It's just too soon to really know for sure on that, but it's a possibility, so worth showing you in the video. All right, let's all lean back and kind of take a little breather here, right? Because that was a lot. We went through it. I'll have another video tomorrow. I'll be on WCCB Charlotte all weekend, keeping you up to date. So the gauntlet never ends here in the world of meteorology, but I wouldn't trade it for anything in the world. And it means the world to me that you hung with me here through the end of the video. If you made it to the end, let me know. And also let me know where you're watching from. Should have said that at the beginning, but let me know where everyone's watching from, and we'll get through this one together. All right, y'all have a great one. Stay safe. See you all next time.